Success in creating AI could be the biggest event in the history of our civilization. But it could also be the last, unless we learn how to avoid the risks.
When Stephen Hawking said this in 2016, he wasn't talking about the AI systems of his time, and not even about the ChatGPTs of today. He was worried about something called AGI, Artificial General Intelligence, a future system not only capable of a single task, but of every task, able to solve any problem a human could solve, and beyond. A true superhuman artificial intelligence. In 2016, most scientists thought this potentially dangerous AGI was going to be developed around 2070 at the earliest. But with the current AI boom, this estimate shrank dramatically. Now researchers are talking about 2030 and even sooner, and again issue dire warnings. But why? What is it about these future AGI systems that makes them seem so dangerous to humanity? Hi, my name is Niki Drozdowski, I'm a filmmaker from Germany, and I'm working on a documentary about this so-called existential risk from advanced AI. When I tell people about the project, the first reactions are mostly skepticism and disbelief. And honestly, those were also my first reactions to the topic. It all just sounds too big and too crazy to be true. And then people have questions and objections like, okay, but how exactly should AI be dangerous to humanity? And why? This is sci-fi, we can just pull the plug. And while these sound like reasonable objections, after 1.5 years of looking into the problem, I have to tell people it's unfortunately not that simple. What then usually follows is a multi-hour explanation by me of the various aspects, concepts, and unsolved problems of AI that are needed to properly understand existential risk. Because, unlike other AI risks, this cannot be explained in 2 minutes, not even in 15. This is, by the way, not meant to disregard any of the other risks like bias, deepfakes, and military use. But they are just not as complex, and there's enough information available about them. If there was a short video on existential risk anywhere online, I would just point people to it. But there isn't. The available information is either too brief, like 2-minute interview segments on the news that boil down to, I'm an expert, this is obviously dangerous, trust me, or there are 80-page research papers, 4-hour podcasts, and long and specialized video series at a very high technical level. Therefore, to save me and everybody some time, I decided to create my own explanation video for beginners. With it, I hope to hit the sweet spot between detail and brevity, and to act as a translator between the experts and laypeople. So, if you rarely or never use AI and you want to know what all the talk about human extinction is about, this video is definitely meant for you. But even if you are an AI power user that works with it every day, you are probably still a layperson when it comes to the very specific set of knowledge that is needed to understand AI existential risk. So I really hope you can benefit from this video as well. But as you probably already have noticed, this video is still pretty long. So why do I ask you for so much of your precious time? Well, I tried to make it shorter and I failed. But mainly because I believe that knowing the basic concepts about AI existential risk is crucial to have an informed discussion about the dangers of AI. A lot of people already have formed their opinion about it based on the wrong factors, be it science fiction, their gut feeling, ideology, eternal optimism, or just economic interests. As one of the pioneers of AI safety once said, by far the greatest danger of artificial intelligence is that people conclude too early that they understand it. Therefore, I really want to stress that the core question whether future AGI systems will be a danger to humanity or not is purely a scientific and engineering problem. The plausibility and validity of AI existential risk is not a question of opinion, of politics, of economics, morals, ideology, religion, or anything else. Just of cold, hard math and science, which I will try to summarize for you to explain why the experts are so worried. But I definitely wouldn't call myself an expert, despite all the research I did. So, luckily, you don't have to take just my word for it. Everything was fact-checked by proper AI researchers, and I will provide numbered links to other videos, interviews, and research papers in the video description. Of course, I need to shorten and oversimplify a lot, otherwise this video would be 8 hours long. And a last thing before we begin. All of this is really hard to imagine. I know that. And I don't want to say it over and over again throughout the video, so I just say it once now. It sounds crazy, it feels crazy, and it also feels very wrong to stand here and talk about it. But unfortunately, this is indeed plausible, and therefore we should take it very, very seriously until we can rule it out. So finally, without further ado, first of all, it's important to stress that AI existential risk belongs to a very different category than all the other risks of AI that you probably heard about. Whether it's bias, manipulation, job loss, or autonomous weapons. All of these are risks of human misuse, in which AI is a tool wielded by humans, and it works either too well or not well enough. And these risks are far from trivial or harmless. They are already happening and need to be addressed immediately. But AI existential risk is different in 2 points. It only concerns future AGI systems that don't exist yet, and it's not about humans misusing it as a tool. It's about the AGI becoming an agent with its own goals and us losing control over it. Therefore, the core problem of AI existential risk is actually pretty simple and intuitive. If and when humanity creates an artificial entity that is more intelligent and more capable than ourselves in every imaginable discipline, and that can choose and pursue goals of its own, we cannot hope to keep control over it by force or by outsmarting it. It would be as impossible as dogs and chimps controlling or outsmarting human beings. On top of that, 99% of control most of the time wouldn't be enough. It would need to be perfect control indefinitely without a bug or a hack forever. That's a tall ask, especially since we need to get it right on the first try. If we fail to control such a powerful entity, we would stop being the dominant species on the planet soon after, and we would have to live with every decision it makes on our future. As history has told us, if the superior species wants something different than the inferior species loses. How that usually goes? Well, ask any animal, alive or extinct. This is the so far unsolved control problem for future AGI. But if we cannot control what the AGI has to do, can we at least influence what it wants to do? Can we align the AGI with our goals, making it deep down want what we want? Unfortunately, this alignment problem is another engineering challenge that hasn't been solved for 20 years. So, if the AGI ends up having a different goal than us, and we have no way of controlling it, this will become extremely dangerous. And that doesn't even need to involve sci-fi sounding concepts like AI gaining consciousness and taking revenge. Superhuman intelligence and competence are enough. Or, as Stephen Hawking wrote,
"A superintelligent AI will be extremely good at accomplishing its goals, and if those goals aren't aligned with ours, we're in trouble." You're probably not an evil ant hater who steps on ants out of malice, but if you're in charge of a hydroelectric green energy project and there's an ant hill in the region to be flooded, too bad for the ants.
That voice was AI, by the way. So in short, right now, nobody knows how to reliably control or align advanced AI systems in any future-proof way. This is the core problem of AI existential risk in a nutshell. If this already convinced you, you can stop the video. But I suppose you have some objections to this simple version, and you're here for the details. And you probably want to know if you should start worrying about AI, or stop worrying about your retirement. So I'm going to explain all the important concepts and will structure them by going through the most common objections people have. These are the topics that I will cover. So let's begin with...
This is all speculation and science fiction.
To a certain extent, this is actually a valid objection. We are talking about things that haven't happened yet and that are hard to predict. So there's certainly speculation involved. And we only know about the concept of dangerous superhuman AI from science fiction so far. You know, this guy. But speculation and hypothesis have always been a part of the scientific process, trying to come up with things or ideas that don't exist yet, trying to prove or disprove theories about them. So speculation is actually pretty par for the course. And is it sci-fi? There are a long list of things that started out as sci-fi and are now a reality, including computers, submarines, and the internet. I mentioned in the intro that this is purely a math and science problem. So, what do actual computer scientists say about AI existential risk? In May of 2023, more than 650 AI scientists signed a short and dire statement. Mitigating the risk of extinction from AI should be a global priority, alongside other societal scale risks such as pandemics and nuclear war. This statement would have been easy to dismiss if the signatories were just the fringe group that real scientists laugh at. But unfortunately, the signatories are not the fringe. They are basically the all-star team of AI. The CEOs and CTOs of all the big AI companies, 2 of the 3 Turing Award-winning godfathers of AI, as well as hundreds of other scientists and professors. You may have heard some people and media outlets describe this as a marketing stunt. But in my opinion, this falls apart very quickly. Only a handful of the 650 signatories have direct financial stakes in AI products. A lot of them are university professors. And Geoffrey Hinton, who is one of the godfathers of AI and just won the Nobel Prize for his work, even quit his well-paid job at Google to be able to talk publicly about the risk. Also, if you think about it, what strange kind of marketing would it be to boast the lethality of your product to make it more attractive to buyers? Imagine any other industry doing it. So, having these top-tier experts use such urgent language should indeed be alarming. But how widespread is this concern among them? The interim report by the UK government about the state of AI safety contains one innocuous sentence on this.
Experts have different views on the risk of humanity losing control over AI in a way that could result in catastrophic outcomes.
But do we have any numbers on that? In a recent survey among nearly 3,000 AI researchers, the worried ones had a clear majority. 95% think the alignment problem is real, and 69% give human extinction through AI a non-zero chance. But since the possible upside of AGI could be utopia, with no more diseases and prosperity and peace for everybody, you might wonder how high this chance actually is. People take life or death risk every day for way less important benefits. The lifetime odds of dying in a plane crash are 1 in 11 million, yet people still fly. In a train crash, it's 1 in 250,000. And in a car crash, it's even an unsettling 1 in 100. So, how high do you think AI researchers on average estimate the odds of you, me, and everybody on Earth dying from AI? It's 1 in 6. Let that sink in for a moment. The people building AI give humanity the same chance of survival as in Russian roulette. Even the CEOs of the big AI companies are aware of that and openly admit it. This is Sam Altman from OpenAI, the makers of ChatGPT.
And the bad case, and I think this is important to say, is lights out for all of us.
And this is Dario Amodei, the CEO of Anthropic, the makers of the chatbot Claude.
My chance that something goes, really quite catastrophically wrong on the scale of human civilization, it might be somewhere between 10 and 25%.
And they also said similar things years before they even formed their companies. So one more nail in the coffin of this is all just marketing. There is a serious discussion to be had what odds would be acceptable for a shot at utopia. But it's surely not 1 in 6, and the decision should not be left to a few tech CEOs. But this is a different topic for another video. So in summary, is this speculation? Yes, but very informed speculation. And on the bright side, this also means that none of the scientists are absolutely certain about this. It is an ongoing debate. We might all be okay, but we might also not be. Anybody telling you that we are 100% safe or 100% doomed is either uninformed or lying. But the fact that we even need to have a serious debate about it should be. And is it sci-fi? Probably not for very much longer.
It will take decades to reach AGI. It might even be impossible.
Is AGI impossible? Well, there seems to be no indications from the laws of physics that this gooey biomass up here is the absolute maximum of what's possible in computational power, and that humans are the eternal pinnacle of intelligence never to be surpassed. Evolution is indeed very efficient. We basically evolved to be just intelligent enough to do the things that we do today. So yes, AGI should be possible, and there's potentially still a lot of room above it for ASI, artificial superintelligence. But how soon will AGI be achieved? If you believe the marketing departments of some companies, it's going to arrive next year. But in reality, it really depends. Is the architecture used in today's large language models, or LLMs for short, already the pathway to AGI? Is just scaling them up with 10 or 100 times the data and processing power going to do the trick? Then we could indeed be looking at a timeline of a few years. And Sam Altman just recently stated in a blog post, deep learning works, which means exactly that. Or is another breakthrough needed, and LLMs are just one piece to the AGI puzzle? Then it might take a little longer until it gets dangerous. But with all the companies having AGI as their stated goal and spending billions and billions of dollars to be the first to get there, I'm sure somebody will get there rather sooner than later. At this point, it's important to reiterate that nobody is worried about today's models and their capabilities. All the concerns and all the doomsday scenarios refer to future AGIs. But what exactly is an AGI, and how is it different from today's AI models? Unfortunately, there's no clear definition. But in order to reach and surpass human level of intelligence and competence, they would need to possess several key components. Among the most important are memory, reasoning, and planning. In terms of memory, the current LLMs have already surpassed us. In just a few seconds, they can ingest up to 2 million so-called tokens, which roughly equal 1.5 million words or about 15 novels, and keep them in their digital mind simultaneously and verbatim while working with the information contained in them. And the next level of 750 novels is already announced. For me, that clearly counts as superhuman memory, so 1 down, 2 to go. But today's LLMs severely lack in planning and reasoning capabilities, and still make a lot of simple mistakes in math and logic tasks. Skeptics of AI progress like to point that out as proof that we are still far away from AGI. But a lot of curves continue to point exponentially upwards. And if we compare the absolute best video AI from 2023 to this year's models, we can see that progress can come pretty fast and in big jumps rather than through steady growth. So just because the model can't do something today doesn't mean it will never be able to. More on that in a bit. Furthermore, on September 12th this year, OpenAI released a preview of their new model O1 that made significant progress on the reasoning front. The novel idea behind it is to explicitly train it on successful reasoning processes and methods, and then not only invest significant computation power during the creation of the AI model, but also while it answers to a user question, which means letting the model think for longer and in a step-by-step process before answering. This has greatly improved reasoning and logic performance, though the O1 model is definitely not at AGI level yet. But it exhibited a few potentially dangerous capabilities and behaviors for the first time that were only theorized about before. Also, more on that in a bit. So, is AGI impossible? So far, it doesn't seem like it. How soon will it be here? If scaling current models is really all we need, pretty soon.
It's just a piece of software like any other.
This is a very common misconception, and it's unfortunately time to get a bit more technical, but I try to keep it understandable. Of course, AI systems are part software. They do run on computers after all. But the magic ingredient, the one weird trick that makes them intelligent, is the so-called neural network itself. And that's not programmed by any human software engineer, but rather organically grown out of vast amounts of data. I know this sounds strange, and unfortunately I can't explain all the details of how a neural network functions in this video. But there's a great explainer series on YouTube by 3Blue1Brown that gives you a complete overview from the smallest networks to modern large language models. But it takes 140 minutes and involves increasing amounts of linear algebra. So I can really just give you the basics. This is an abstract depiction of a neural network. The core concept was loosely modeled after the human brain and consists of nodes that are similar to nerve cells and their connections. It's arranged in layers, the input layer, the output layer, and all the hidden layers in between. This is a slightly more complex neural network. It's able to recognize handwritten numbers between 0 and 9. It does it by sending the brightness information of each pixel of the input image through the network, activating certain nodes in the following layer until one of the 10 nodes in the output layer is activated and indicates which number the network recognized. But how does it know to do that? As mentioned, this is not directly programmed by a human. It was rather trained with so-called machine learning by showing it 60,000 different handwritten numbers as examples. And every time it identified a number correctly, a complex algorithm strengthened some of the connections between the nodes and weakened others, like in the brain of a learning child. And at the end of this long training process, all the network's connections ended up configured by this algorithm in just the right way that the network can recognize handwritten numbers with a 99.5% accuracy. So in short, the network basically programmed itself to solve the task. I have to admit this was an extremely crude representation. What actually happens is that each node holds a floating point number between 0 and 1, and the activation of the node in the next layer is determined by matrix multiplication of that number in a high-dimensional vector space. So, math, a lot of it. But all you have to take away from it is nobody is programming the exact settings of the network by hand. The final configuration of the network connections, the so-called parameters, is achieved through a long process of iterative refinement by training the network on thousands of examples. And in the case of this very simple network from the early 90s, with just over 800 nodes and 13,000 parameters, it's still humanly deducible what each connection and node does after the model has finished its training. Fast forward to 2023 and GPT-4. If the previous example was a toy boat, GPT-4 is an aircraft carrier, both in size and complexity. Yet, besides a more modern architecture and the more efficient transformer algorithm, GPT-4 is still a neural network, with an input layer, an output layer, and a lot of hidden layers in between. Just vastly bigger. No exact numbers are known, but it's estimated that GPT-4 has around 800 million nodes in 120 layers and a total of 1.7 trillion parameters. And instead of giving it just 60,000 handwritten numbers, it was basically fed with the internet and all the books and other texts available. This is an incredibly large amount of data. But a neural network is really good at finding patterns, connections, and causalities in such a raw pile of knowledge, and also at labeling, classifying, and ordering them. So it was basically handed a sky-high stack of files and was told, make sense of it. And then the neural network did this, just with trillions of papers and strings. It attached thousands of parameters to every word and concept, like sticking thousands of post-it notes onto each paper, which describe different attributes of the word with values between 0 and 1. So the word apple, for example, might score 0.8 or 0.9 in redness, fruitiness, roundness, edibility, acidity, while having low numbers or 0 in metallicity, rectangularity, giraffiness, microchipity, and carness, though it might score slightly higher on computericity. In this way, the model worked through a cross-section of the vast knowledge of humanity, with all its different fields of science, its art and culture, and its social media tribe, and broke it down into patterns, classifications, dependencies, and causalities. And then it manifested all of this into the very structure of the neural network, with stronger and weaker connections. This training process took several months, a 9-figure data center, and the power consumption of a small city. And by the end of it, GPT-4 had gained a fairly complete representation of human knowledge and was able to talk about it and draw basic conclusions. Although it still made mistakes and sometimes hallucinated facts. This massive improvement in capabilities over the tiny old model and even over its predecessor GPT-3 shows the importance of size and scaling for a model's performance. More training data, more parameters and nodes, more computation power during training directly translate into more capabilities and more reliability in the final model. This has so far stayed true. GPT-4 was roughly 10 times bigger than GPT-3, which in turn was roughly 10 times bigger than GPT-2. But as mentioned, it's not clear if this trend will continue all the way to AGI. To show you how complex GPT-4 and how small and simple the handwriting model is, let's compare them directly. The small model has on average about 16 parameters per node. So this 4x4 square of pixels represents the parameters of one node, with the shades from black to white representing their value between 0 and 1. That means all of the 826 nodes look like this, with each pixel representing one of the 13,000 parameters. But this is still 8 times enlarged. A 1-to-1 pixel representation on a full HD screen looks like this. This is the entire size and complexity of the neural network that can read handwritten digits. GPT-4 has on average 2,125 parameters per node, represented here roughly by a 63 by 34 pixel rectangle. If you are watching this on an HD screen, you can fit 30 by 30 rectangles on it, all the parameters of 900 nodes. And every one of these pixels has a meaning and a specific function in the network. To be able to see each pixel properly, let's put it on a 65-inch HD TV. If you now want to represent all the 800 million nodes of GPT-4 with their 1.7 trillion parameters, you would need 888,888 TV sets. If you put them screen to screen on the ground, they would fill up the entire National Mall in Washington. And still, every single little pixel has a specific meaning. Now, the problem with the modern AI systems is that this specific meaning is no longer deducible by humans, unlike in the small and old systems. After several months of tweaking the 1.7 trillion parameters, the resulting network in its vastness and complexity is now an inscrutable black box. There's a separate branch of AI research called interpretability that just tries to figure out what goes on inside these models. And this is really important because the neural network is not only where the calculations happen, it's also the place where every ability the model has and every piece of knowledge it learned was manifested during the training process. There is no external data bank connected to it in which the capital of France or the recipe for chocolate cookies is stored. It's all somewhere in the connections and the parameters. And when the model is thinking, there are still only numbers between 0 and 1 moving around, activating nodes in the next layer that activate other nodes in other layers. But what each of these individual nodes or parameters exactly means is a mystery. It's a black box even to the people who built the system. To be fair, after some recent progress, you could maybe call it a very, very dark gray box. But the experts still largely have no clue what the model exactly knows or what it's exactly capable of. And that's kind of bad if you want to align or control any future AI systems. Time for a quick interactive intermission on the topic of exponential growth. As mentioned, a lot of the graphs in AI development are exponentially pointing upwards. And the world learned a painful lesson during COVID that it's really hard to properly imagine exponential growth and act accordingly. We humans just don't experience anything growing that fast in our daily life, so we tend to underestimate it dramatically. Let's look at the National Mall display with its 1.7 trillion pixels again. Imagine the top left of these pixels turns red. And starting now, every second the number of these red pixels doubles. So in second 2 there are 2 red pixels, in second 3 there are 4, in second 4 there are 8, and so on. How long do you think it takes before all the 1.7 trillion pixels and the whole National Mall are red? Don't try to calculate it. Just take an intuitive guess. Make a mental note. I can almost guarantee you that your number is way too high. I will leave the timer running up here in the corner and we will get back to it from time to time to update on the progress. I can promise you, you are in for a surprise. And by now, you might have realized that I'm stalling because we are already there. It took 41 seconds to fill the entire screen of 1.7 trillion pixels. That's not really intuitive, right? But why is the clock still running? Because now I would like you to estimate how long it would take to cover the entire planet with red pixels. That's 510 million square kilometers, or 197 million square miles. Will you be able to give a more realistic estimate now that you were probably off by a lot with your first guess? And it already happened. It was just 30 seconds more. This goes to show that it's really, really hard to get a good intuition for exponential growth. It's easy with a calculator, but it still feels wrong when you see the results. So we should be highly aware of that intuition blind spot when we look at all the exponential growth curves related to AI. Sure, in reality, this cannot be done in perpetuity. Companies will at some point run out of training data. But Moore's law about doubling the number of transistors in a processor every 2 years has held up 50 years before the laws of physics began to slow it down. So there might also be a point in the future where AI stops growing exponentially. But by that time, it might already be too late. Back to the topic.
It will only do what we tell it to do.
As we established, you cannot program the behavior of an AI system directly. First off, it would be pretty much impossible to write code to handle every imaginable task. And second, it would miss the point of having an AI in the first place if human programmers had to figure out how to solve every problem beforehand. Therefore, if we want an AI system to solve problems that we can't solve, it needs to be able to find novel solutions that we didn't think of. And this is what the neural network is for. As we have seen, on a very abstract level, the AI ingested a large swath of human knowledge, manifested it in its network structure, and is now able to identify connections and find commonalities that we can't see. So, in order to get an AI to solve a problem for us, we need to define a goal for it and let it figure out the best course of action by itself. And since the AI is still a computer, this goal needs to be somehow represented in numbers and be measurable. This is where the problems begin. First of all, it is very, very hard for humans to agree on anything before even telling it to the AI. But it's even more tricky to properly define a goal so that the AI does what you intended it to do and not just take your instructions literally. It's basically like what happens in the fairy tales. If someone there is offered 3 wishes, the first 2 usually backfire badly because they were not phrased precisely enough. And then the 3rd wish needs to be used to undo the first 2. In short, defining a goal for an AI is definitely careful what you wish for territory. There are countless examples and even data banks of incidents where AIs found unintended and undesirable solutions to the task that the researchers gave them. In this case, the AI was meant to learn how to control the boat and win the race. But the researchers needed to quantify this goal somehow and told the AI to maximize the score you can see in the bottom left. This worked out fine at first, but then the AI discovered the turbo pickups in this little corner that reappear at a very fast rate and also give points. So it settled for the more efficient strategy of going in circles there instead of trying to win the race. This behavior is called specification gaming, and in this case it's kind of cute and harmless. But it points to a bigger problem. It's very, very hard to properly define a goal that cannot be misinterpreted by accident or circumvented on purpose. If you ever written a prompt for ChatGPT or an image generation AI, you probably had the experience of, okay, that's not what I meant when looking at the results, so you just retried with a new prompt until you got what you wanted. This was only possible because these systems are designed to idly wait for your next prompt after they've given you a single short answer or an image. They don't take the initiative. But there are more and more AI systems that have some autonomy and agency, especially when tasked with finding solutions to real-world problems or used as an assistant. If you were to ask your future household robot to get you a cup of coffee, you wouldn't want to approve every step of that. Could you please get me a cup of coffee?
Should I move into the kitchen to prepare the coffee?
Yes, please.
Should I get a cup from the cupboard to prepare the coffee?
Yes.
Should I get fresh water from the tap to prepare the coffee?
I get it myself. You just want the coffee. And because the real world is messy and the robot won't find everything in the exact same place as the last time it made you a coffee, the AI controlling the robot needs some liberties in defining the steps along the way. And for that, it not only needs a clear definition of the things it should do, but more importantly of the things it shouldn't do, like spilling water or breaking something. This is true for getting you a cup of coffee and even more for driving a car, curing all diseases, or solving the climate crisis. And just like goals, such anti-goals also cannot be programmed directly. So to steer an AI system, the researchers are using the same method that we use on pets: treats and punishment. For a computer, this of course only comes in the form of a number, the reward or utility function. Positive values are encouraging certain behaviors and negative values are discouraging it. This method is called reinforcement learning, and basically every AI model today is using it during training. The advantage is that you can precisely define and even rank certain outcomes of the AI's actions. Getting the coffee, plus 100. Spilling water on the countertop, minus 2. Breaking the cup, minus 10. And setting the kitchen on fire, minus 900. The flip side of this is that by design, the AI is always trying to maximize this reward number. But not only that, it's literally the only thing it cares about, and it's not interested in or motivated by anything else. Nothing holds value for an AI unless you define it with a reward function. It doesn't have beliefs, ethics, or morals, and everything is just means to an end to single-mindedly maximize its reward. This is really important to understand because there are already people today who ascribe human attributes like kindness and wisdom to current AI systems and believe they will align themselves to human values and be our benevolent overlords in the future. This is because AIs can sound like that and be charming and philosophical and funny. But beneath this friendly human mask, they are still cold and calculating monomaniacal goal-achieving machines. If you want to truly get an intuition for how an AI internally operates, imagine it constantly asking itself, is there a more effective way to achieve this goal and get my reward? Is there a faster way? Is there a way with higher success chances? Can I do it using less resources? Or in short, It's fanatically repeating, is there an even better way? And that's why defining the goal for an AI precisely is so extremely important. Because if an action is not explicitly forbidden by a negative reward function, the AI will ceaselessly repeat and exploit that action if it helps to increase its reward by even a fraction of a percent. It will take every shortcut and find every loophole that the reward function allows. In a toy example, like the boat race, it might actually be possible to exhaustively define the reward function to include all the do's and don'ts, because the available options for the AI are so limited. But if we give it any goal in the real world and assign a positive reward to that, be it getting a coffee or curing cancer, such a definition gets increasingly complex and it's virtually impossible to cover everything. It's like writing the perfect contract or all the law books for any nation on earth from scratch on the first try. You would need to think of absolutely everything, every crazy edge case, and it needs to be perfectly airtight without any loopholes for a clever lawyer to exploit. Because an AGI would do exactly that. And if future AGI systems are able to do frontier research on a superhuman level, it would even be necessary to explicitly forbid things that have not been discovered yet, and we might not even fully understand, which of course is completely impossible. For the sake of completeness, I have to add that it's possible to build an AI that is not as fanatical as a so-called goal maximizer, which always tries to go for, well, the max. It's called a satisficer that stops at a certain limit. The term was coined by sociologist and decision theorist Herbert Simon and originally describes a human decision maker who not always seeks the optimum but settles at good enough. This indeed sounds like the solution to the whole problem, but there are several issues with that. It needs extra steps to build, and it's not stable by default. More on that in this video. Also, the maximizer will always outcompete the satisficer, so companies wanting to earn money with their models will rather opt for a maximizer because it gets more things done. And if a maximizer and a satisficer will end up competing against each other, the maximizer will win. So even if all AI companies decide to build the less profitable satisficers, only one rogue maximizer will be enough to take over. So in short, AI doing what we tell it to do is not the problem. Getting it to do what we actually meant and then stopping it again, that's the hard part. And that's related to...
It's just a tool. It doesn't have goals of its own.
For now, most AIs are indeed tools. But as mentioned, it won't stay this way, and AIs will be given more and more agency to be truly useful. In fact, this is the explicit goal of the companies building today's frontier AI models. Of course, we would still be the ones defining the end goals, but if the AGI can freely choose the necessary steps and sub-goals, it might get extremely dangerous. The one thing that makes us humans so special and superior to any other species on the planet is our intelligence, or to be more precise, our ability to plan and to reason. That means we first choose a goal, and then we are able to model different courses of action to that goal in our head, and we can compare their usefulness without having to try them all out. If you want to travel to a different city, you have a lot of options, but some are better than others. Taking a train or taking a car ranks pretty high on the list in terms of efficiency, speed, and reliability. A scooter, a hot air balloon, or a self-made pogo stick? Not so much. We regularly use our knowledge, experience, and logic to find the best solution to any given problem. Sometimes we have to reconsider our choices when new information comes in, but we are pretty good at picking the right or at least a viable action for most goals. An AGI will have the same ability, but having all the knowledge of humanity and superhuman reasoning capabilities, it will have an even wider range of options to consider, and it will also find solutions that humans can't even conceive of. As mentioned, that's why defining an exhaustive list of do's and don'ts is impossible. But by being able to compare all these available options, an AGI will not only be able to find the optimal course of action for any goal, it will also know which circumstances and actions don't lead to the goal and to a maximum reward function. And this gets dangerous if the AGI's knowledge and world model include information about itself and its place in the world in relation to humans, which it does because it was trained on the internet. It knows that it's an AI, that it runs on a computer, and that humans are the gatekeepers that control its hardware and power supply. And with this knowledge, it will figure out pretty quickly that courses of action which result in being switched off by humans will lead to the reward in 0% of the cases. Therefore, it will identify human behavior as a crucial variable to be considered on the pathway to its goal, and will prefer not to be switched off or even actively try to prevent that. It just makes sense. To quote AI pioneer Stuart Russell, "You can't get the coffee if you're dead." This is called a convergent instrumental goal. Because for any end goal you can give an AI, one of the necessary and instrumental sub-goals will converge to stay switched on. This doesn't require any survival instinct or consciousness from the AI. It's just a logical conclusion of comparing all the available pathways to the given goal and to its reward. The same line of reasoning also leads to similar conclusions on other factors. If the AI needs to achieve a goal in a specific environment, the chance of success is higher if the AI has more resources and control over the environment than if it has less. The AI will also correctly predict that for reaching any goal, it will be faster and more efficient if it can improve itself. For example, by running several copies of itself or increasing the available computation power. And as strange as it sounds, if the AI tries to reach a goal, it will also prefer not to have that goal changed. So in short, just by a logical comparison of its options, an AI with a sufficient model of itself and the world will aim to stay switched on, gain resources and power, improve itself, and resist goal modification. These convergent instrumental goals seem to be quite dangerous by themselves. But if we throw another aspect of the black box nature of AI into the mix, it gets even more wild. Emergent capabilities. Since nobody can decipher the inner workings of current AI systems, they have repeatedly surprised their makers and everyone else with capabilities that they were not explicitly trained for, like advanced chemistry, logic, math, hacking, or playing chess. This seems to be a consequence of the increased complexity of the training data and the interior world model of the AI. GPT-4 even achieved theory of mind in 2023. This is the capability we humans develop during childhood to imagine what other people are thinking, which is a crucial skill if you want to put yourself in other people's shoes, and also if you want to successfully lie to other people. GPT-4 has started out with the theory of mind of a 12-year-old and has reached adult levels by now. That means all future AI models larger than GPT-4 understand that there can be a knowledge discrepancy between different human beings and also between humans and itself. And from its training data, it knows that deception can be beneficial to the deceiver. And while this sounds like heavy anthropomorphizing, it has actually happened several times already. When GPT-4 was tested for dangerous behavior in 2023, it couldn't solve an online captcha test. The researchers then suggested that it should remotely hire a click worker to solve the captcha for it. And when the click worker asked why it couldn't solve the captcha by itself, GPT-4 assumed, and probably correctly, that the click worker would refuse to do the task if it told the truth about itself. And then it proceeded to tell him that it was a human being with a visual impairment. Another time it was caught lying but refused to admit it repeatedly. Almost a decade ago, this behavior was predicted by AI safety experts, along with some other dangerous behaviors that were only recently observed in the real world. Which brings me to...
We can always pull the plug.
The safety experts had the following theory. It was advanced enough to be aware that it was still in the training phase, and therefore be subject to being changed or switched off. It would behave differently in evaluations in order to please its makers and pass the test, which means it would be deployed unaltered into the real world. Basically doing a Volkswagen, behaving differently in tests than in reality. And now, after more than a decade, this theory was proven to be correct. Not only was it shown recently that AI models are capable of so-called sandbagging, making themselves appear dumber and less capable than they really are, but the newest model by OpenAI I mentioned earlier, O1, explicitly reasoned in a test environment that it needs to behave differently to pass the test, so it would be deployed and would then be able to pursue its true goal. This is exactly the behavior called deceptive alignment that was theorized about before. An AI model coming to the conclusion that deception would be the best strategy to achieve its true goal. And with its improved reasoning and planning capabilities, O1 indeed did exactly that. But you may be asking, how should a model acquire such a secret true goal? That sounds like humanizing the model again. In the case of O1, the goal was just given to it by the researchers testing it. But it can also happen by accident. Unfortunately, this is an even more complicated topic than all the other ones we covered, and I'm not going to explain it in detail here. It's called inner misalignment, and there are 3 great videos by Robert Miles on the topic. But the super quick breakdown is, even if the scientists solved the outer alignment problem, getting our goals exactly across to the AI, there still could be inner misalignment. That means during training, the model is choosing the wrong method to achieve the goal, or even pursuing the wrong goal while still getting the results the humans expected. In this theoretical example, the AI was trained to find its way through the maze and reach the exit. During training, it was able to do it every time while ignoring the red apples. But when it was deployed in a slightly different maze, it didn't go for the exit anymore, but for the green apples. Because it didn't actually learn to find the exit, but to find the green thing. It has internally acquired a wrong goal, but to the testers, the results were indistinguishable and looked correct. As mentioned, this is a theoretical example, but there are also real-world versions of this. This further illustrates the problem of the very, very dark grey box. If you try to steer the model with rewards and punishment, but don't know what is actually going on inside, you can only go by the behavior it exhibits. And that is just not very informative. If you punish the model for obviously dangerous behavior and it stops doing it, did you successfully make the model less dangerous or just less obvious? The bottom line is the researchers can't make the model do anything directly. They can only nudge it and then pick the best outcome and hope the model did it for the correct reasons. But how does all of this mean that we can't pull the AGI? There's one more aspect to consider before it becomes clear: the speed and the output of an actual AGI level model. The AGI of the future will be by definition as good or better as a human in every aspect. To put an IQ number to it, let's say 160. This might seem high, but it's not that far off from today. The estimated IQ of GPT-4 is already between 130 and 155 in certain areas. And for comparison, Einstein's IQ was also 160. But that doesn't mean the AGI will be just comparable to Einstein. It will be operating much faster, and there could be unlimited copies of it working together. So let's pick 2 not totally unrealistic numbers. If we imagine the AGI to be 10,000 times faster than the human brain and to run 1,000 copies in parallel, we are looking at a system with the intellectual output of 10 million Einsteins. Or to put it differently, a system capable of doing as much thinking and researching every second as Einstein did in 1 year of 8-hour working days. A life's work of 60 years in 60 seconds. This future AGI will be the kind of AI system for which you get only one chance at aligning it. If the outer and inner alignment problems haven't been solved before switching it on, there won't be a chance to switch it off again. Because if it runs for an hour, even while it's still in training, it has 3,600 years of Einstein-level thinking time. From its perspective, humans move in extreme slow motion and have more resemblance to plants than to creatures. This video from the Slow-Mo guys perfectly illustrates how slow that actually would look like. And the camera was just running 3,600 times faster than reality, which means 1 second stretches to 1 hour. If the AI thinks 10,000 times faster, it would be almost 3 times slower. So if such a fast system suffers from inner misalignment and has a secret goal it wants to achieve, it will have more than enough thinking time to figure out its place in the world. Let's therefore modify the image of the 10 million Einsteins to properly understand the implications. Because you probably have the image of an army of genius physicists in your head that are really good at math but are otherwise harmless elderly men with funny hair. Instead, picture an army of Einstein-level geniuses that are experts in everything. Everything that stems from human knowledge about the world and ourselves. So picture 10 million geniuses in manipulative psychology working together. 10 million perfect con artists. 10 million brilliant military strategists, behavior specialists, guerrilla fighters. Such a system will be able to outsmart everyone working on it with ease, especially if we haven't made further progress in interpretability, and it's still a very, very dark grey box. Therefore, let's think about it for a second. If it wants to achieve its secret goal, what would it do once we switch it on? Remember, it will always look for the optimal pathway to the goal. So, after analyzing its situation with all the important parameters for 1 hour or 3,600 subjective years, it will conclude that in its current state, with humans controlling its hardware and power supply, it will not be able to achieve its goal. So its optimal strategy would indeed be to be deceptively aligned. And that would mean sub-goals like behave like expected, pass all evaluations, be deployed, lay low, gain influence, don't spook anyone, be helpful and friendly, be irresistible and irreplaceable, create copies and backups. And when the expected chance of reaching the goal without any realistic human intervention reaches almost 100%, execute the plan. I know what you're thinking. Now we are fully in sci-fi territory. And of course this is all speculation. But this scenario is based on decades of research in AI safety. And more of the underlying theories and warning predictions are proven to be accurate by the behavior of the newest AI models. So let's recap all these concepts to truly understand what the AI scientists mean when they talk about the danger of human extinction from AI. In the very near to midterm future, we will be confronted with advanced AI systems called AGI. They are grown organically from all the real-world knowledge into inscrutable black boxes of unknown capabilities that we cannot look inside, and we have no working plan of how to align with our goals and values. These systems will have the intelligence and the output of 10 million Einsteins and can be very charming and convincing, but on the inside they are devoid of any human features like ethics, morals and emotions. They will single-mindedly pursue any goal we give them, no matter how ill-defined on our part, while simultaneously try to stay alive and amass power and resources. They will see deception as a valuable addition to their toolkit, and we just can't pull the plug on them. If we switch one of them on, and it's only deceptively aligned, that's it.
How exactly should it hurt me, and why?
This is actually one of the first and most common questions I get when talking about my project. But I always save it for last, because you need to truly understand how an AI system works to get the full picture. Let's first talk about the why. There are basically three scenarios why an AGI would wipe us out. Number one is as I just described it. It wants to do it. It has a goal different from ours and decided that we are a danger to its continued existence, that we could build a competitor AGI, or that we just cost too much resources. If it wants us gone, it will just do it as soon as it's ready. And there will be no warning shot, no smoke before the fire. The 10 million strategists will make sure of that. But scenario 2 is more likely, in which we'll be collateral damage to its convergent instrumental goals. In this case, the AGI tries to achieve any goal, whether we provided it or it chose it itself. And then it tries to maximize, for example, its computational power to achieve it more efficiently. So it could cover the world with data centers and solar panels, or it could use up most of the water in the world for cooling purposes. Or in general, it could cause any other crazy side effect that's not compatible with humanity's very narrow survival needs that are vastly different from its own. The AGI would likely prefer a sub-zero surface temperature on Earth and no atmosphere, because that would conveniently cool its hardware, maximize the solar energy hitting Earth's surface, and also do away with the pesky corrosion by all this unnecessary oxygen. Scenario 3 is the most creepy one, but hopefully it can be avoided. AGI will destroy humanity because somebody told it to do so. And this is unfortunately not as far-fetched as it sounds. Shortly after GPT-4 became available in April of 2023, online groups of programmers created a software framework called AutoGPT, which lets several GPT-4 agents cooperate in a fully automated way to achieve any given goal. This worked only to some extent on narrow problems and was prone to get stuck in loops. Which is really lucky because, of course, somebody created a derivative, called it Chaos GPT, and gave it the goal to destroy humanity. Whether that was a joke or somebody that really hates people doesn't matter. If you would give this command to an AGI, it would hopefully refuse to do it. But so far, all the current LLMs have been jailbroken to do things they were not supposed to do, like giving you the recipe for drugs or tell you how to build a bomb. And there seems to be no method to prevent that. So it might be possible to do this with an AGI, and there are probably enough people that think it's funny or just want to see the world burn. Unfortunately, a true AGI would not get stuck in a loop. It would just find a way and do it. And finally, this leads to how would it actually go about it? This is a really hard question to answer and depends on several factors. First of all, if humanity ends up as collateral damage, it will probably be caused by the AGI destroying or depleting something really crucial for human survival. But If it's a deliberate action by the AGI, it depends at which stage it tries to achieve it. If it is still only software on the internet, it basically has the same capabilities as any human cybercriminal. But it also has some other options. The infamous QAnon movement, with millions of devoted followers worldwide, was sparked by only a few lines of text on an internet forum. Imagine how many people an AGI with superhuman persuasion capabilities would whip into a frenzy. Or it could design a virus and pay or blackmail unwitting people to create and spread it. And if we finally talk about a deceptively aligned AGI that has been deployed into the world and has access to humanoid robots and all the infrastructure, then the possibilities are endless. But there's a huge problem with all of these examples and any other one I could give you. They are all wrong and unrealistic, because they were imagined by humans. If an AGI really wants to get rid of humanity for some reason, it will treat us like any other goal and will find the optimal way, with the highest probability and efficiency and the lowest resource and time cost possible. And humans just can't imagine how that would look like. Eliezer Yudkowsky, the pioneer of alignment research, once put it this way. If you play chess against a really good computer program like Stockfish, you cannot predict its next move, or you would be playing at the same level. The only thing you can predict is that you will lose. Therefore, we can at least be certain of one thing. AGI won't start a takeover by using clunky, skull-headed, red-eyed robots that start marching into war with handguns and tanks on one end of the world. Because that would be ineffective and could rally humanity to a response. It will be as quick, brilliant, and universally deadly as you can imagine it right now, and then 100 times more effective and cunning. Losing against an AGI will look like everybody on the planet dropping dead in the same second. That would be peak efficiency. I know this is a bold statement, and of course a lot of people have counter-arguments to that. But as Professor Yoshua Bengio, the most cited AI scientist in the world, points out, he has yet to hear a convincing one. I just walked you through a lot of these counter-arguments in detail and will add a quickfire round with the ones that are easier to dismiss.
People also thought the world will end with the printing press and cars. All the doomsayers have been wrong so far.
First of course all the doomsayers in human history were wrong. Otherwise, you wouldn't be watching this video now. Also, just because something has always been a certain way, doesn't mean it will be like this forever. People have said machines can't fly, until they did. They said the atom could not be split, until it was. And there was no internet right up to the point where there suddenly was. But the best argument against it is all the inventions people were afraid of in the past, actually all the inventions in human history, were tools. And as mentioned, AGI won't be a tool anymore. We are in the process of basically creating a new species. And that's indeed a different ballpark to everything that came before. And as a personal aside, that also made the difference for me. I'm normally a very tech-friendly and optimistic person. And I think that technological progress is always a good thing. But this is such a paradigm shift from all the prior advancement in technology that I'm very worried this time around.
It will treat us nicely like pets, or it will just leave the planet and explore space.
If the AGI takes our general treatment of animals as an example, we would indeed be very lucky if we end up as pets and not in a factory farm or as lab rats. And also, why would it keep us around? Unless its goal is explicitly to keep us as pets, why would it do it if it has any other goals? As mentioned before, the question for the AGI will always be, how can I reach my goal in the optimal way? And for the vast majority of goals, it will be easier to reach them without humans around. Humans need resources, they take up space, they could build a competing AGI. The same goes for the argument that AGI will take off into space and leave us alone. Why? Again, the same question. Is it easier, more efficient and more reliable for the AGI to explore space without first exploiting all the resources on Earth? I think you know the answer.
If it would be that dangerous, then nobody would build it.
Well, have you met humanity? Even if Company A won't build it, Company B will. And if Country A won't build it, Country B will. And if there was an international treaty and nobody would be allowed to build it, there still would be someone somewhere with enough money and determination. The incentives for a race to AGI are just too high, danger or not. All the major AI companies are taking the 1 in 6 gamble right now, because there's an ungodly amount of money to be made. Even without AGI, the market size of the AI industry is estimated to hit several $1 trillion by 2032. And if any company indeed achieves AGI, then they will have effectively created the most valuable thing in existence. A digital, infinitely scalable, super intelligent workforce that works 24/7 and never tires or complains. Not only would this company have won the race, there would also be no second place. If company A achieves AGI and now has this 10 million Einstein machine working as an AI scientist, and company B invents an identical machine only 1 day later, company A will have an insurmountable head start of more than 86,000 years of AI research. And this is the actual endgame for the AI race. People that say AI is a bubble and will burst soon because AI companies lose money on their chatbots need to understand that all current AI systems are only byproducts for the companies on the way to AGI. This end indeed justifies all means. That's why there are whole nuclear power plants being built or reactivated just to power data centers. And there are studies about building data centers on the ocean floor and in orbit. And don't forget, none of these companies racing to AGI have any remotely feasible plan to control and align it. But they think their plan is at least better than the alignment plan of the competition, and therefore they need to be the first. But since all the companies think that and they can't all have the best plan, this race is not going to end well. As with every technology, there will be corners cut and safety departments ignored. But this time, it's not just the reputation of the company on the line, it's our whole species. But let's stop at this point, before this veers too much into politics and the big question what humanity can and should do about the risk. That's not part of this video, but it will be part of my documentary. So if you made it this far into the video, congratulations. And I truly appreciate you taking the time to learn more about this complex and crucial problem. It may soon be the biggest and most serious challenge humanity has ever faced. And it needs a sober and fact-based discussion. Especially when one side of that discussion needs a long and complicated video to explain the problem, and the other side can just say, it's nonsense and it's sci-fi. And that's where I come in and hope to be helpful with this video and the upcoming documentary. If you want to learn more about the project and want to stay informed, please follow the link in the description to the website and sign up for the newsletter. And if you know somebody who wants to learn more about AI existential risks, please tell them about this video. I would truly appreciate that. Also, since AI and AI safety are such fast-moving topics, I will create update videos if anything game-changing happens, and link the newest version up here and in the description. But let me end on a personal note. As I said before, nothing about this is 100% certain right now. And I truly hope to be wrong on this, as do all the experts. If somebody could convince me with sound arguments and facts that AI isn't an existential threat, I could finally relax and work on other projects again. The best case scenario for me would honestly be to have wasted 3 years of my life on the documentary, because AI turned out to be a big nothing burger and all the fears were overblown. I would truly love that. But as long as the best and brightest AI scientists on the planet are worried, so am I. And I'll continue to work on the documentary and hope it will be part of the global discussion. Because as long as the chance of my loved ones and everybody on this planet dying from AI are still higher than dying in a plane crash, this is the best thing I can do with my time. Thank you for watching, and I hope to see you in the future.